Welcome to this video on mathematics A levels. We're going to begin this topic on quadratics, and we're going to focus on how is it that we can solve quadratic equations. And that's going to be our goal for this video. The idea is I'm going to show you all three methods that we can use to solving quadratic equations, and in general you're going to be able to choose whatever method you prefer best, except for some particular exercises where the completing the square method is going to be asked for. So we're going to focus a bit more on that as well. So we're going to start with our first method on how we can solve quadratics. That first method is the method that we call factorizing. It's a very common method throughout the education system. Not that common here in Uruguay, where I'm from. We don't use it that much, but I know that the English-speaking countries do use it a lot. So let's first of all focus on how this is going to work. Let's say that we have an expression that is factorized. Let's say a plus alpha multiplied times x plus beta. Well, here, if we take some distributive rules, we would be doing something like this, and then something like this, and we would be getting x times x will give you x squared, then x times beta will be giving you beta x, then alpha times x will be giving you alpha x, and then alpha times beta will be giving you alpha beta. And here we can factor out an x. Observe that here we have an x that is repeated here and here. So we could be saying something like that this is equal to the x squared. Then on x we will have alpha plus beta x, and then we will have alpha plus beta. So this process that is developing the expression is like we are going to expand it. It's not what we're looking for. We're just trying to show how the method is going to work, but on the other side. It's like, okay, so we're going to take, instead of having an expression that is factorized and expanding it, we're going to attempt to do the reverse process. We're going to have something like this, and we're going to attempt to turn it into something like this. The idea is to go from there. So let's say that we're going to copy the expression here. We said that x plus alpha times x plus beta, sorry, yeah, x plus beta, this is equal to x squared plus alpha plus beta x plus alpha times beta. So what we're going to focus here is we're going to focus on which terms appear in my equation. So for example, let's say that we're going to solve here, we're going to solve x squared plus let's say 5 is equal to 6x. This is going to be our equation. So the first thing that we need to focus on is we're going to have rearrange it so that this is equal to 0. So first, let's say that's going to be x squared. I'm going to subtract 6x to both sides, and we're going to have negative 6x here, and then we're going to add 5 and equal to 0. So this negative 6 that we have here, there, is going to be playing the role of our alpha plus beta. Okay, so we have that alpha plus beta is going to be equal to negative 6. And then we're going to have this 5 over here that's going to be playing the role of alpha beta. So we have that alpha times beta is going to be equal to 5. So from there we have our focus that we're going to be looking for, and we need to think of which numbers alpha and beta work so that these conditions are matched. Alpha plus beta has to be equal to negative 6, and alpha times beta has to be equal to 5. The idea for this method to work is that these numbers must be easy to find. If we have to use rationals or we have to use irrationals, then it's not going to be the most effective method. Do something different. We need to think of this as something that would happen easily. So we can say from this one, I can only think of two options because the prime factors of 5 are either 1 and 5, because 1 times 5 gives you 5, or negative 1 and negative 5, because negative 1 times negative 5 also gives you 5. So my options for alpha and beta are going to be 1, 5 and negative 1, negative 5. These are my options. There's no other way around it. I mean, there are other numbers that I can use that give you 5, but those numbers would not be integers, and then the method would not be easier, and I want the method to be easier. So I'm going to just stick to this. And then I need to think of, well, these numbers that I have here, 1, 5 and negative 1, negative 5, when I add them up, do they give me negative 6? Well, clearly 1 plus 5 gives you 6, so that's not going to work. But negative 1 and negative 5, if I add them up, then I get negative 6. So this is the option that works. We can say that, for example, alpha is going to be equal to negative 1 and beta is going to be equal to negative 5. Observe that it doesn't matter which one is which. You can choose one to be negative 5 or the other. In this particular case, it's not going to be a problem. So from there, we can say, well, great. So this means that this equation that I have here can be expressed in these terms by using these values. But then this equation here is the same as this equation here. So then I can rewrite this equation using this expression but changing the values of alpha and beta. And thus, the equation that I have here becomes x minus 1 times x minus 5 equals 0. You see what we're doing here? What we're doing is we are factorizing, we're turning this expression, x squared minus 6x plus 5, we're turning it into x minus 1 times x minus 5 equals 0. If you were to do the distributive rule here, you will get a here. That's the point of the process. So that, okay, we have it written like this, but now we must remember that this is a product, and the product will give you 0 if one of the factors is 0. So for example, we can say, okay, well then, yeah, x minus 1 has to equal to 0. Let's say that x minus 1 is equal to 0, hence x is equal to 1. And then we have one of the solutions for the equation. And then we can take this equation here, and we can say, well, so the other option is that x minus 5 is equal to 0. And then x is just 5. So which are the solutions for the equation that we were given here? Remember that we're trying to solve this equation, x squared plus 5 is equal to 6x. The solutions are 1 and 5. Note that, for example, 1 squared plus 5 gives you 6 times 1, so that is correct. And then if I put in 5, it's going to be 25. 25 plus 5 is 30. 6 times 5 is 30. So everything works out, everything checks out. This is one of the methods. It's called the factorizing method. And it's a method that here in Uruguay, for example, we are not used to working with. So it may be a bit challenging for us students, but it's a very interesting method. If you can practice it, it's a very interesting one. Now we're going to focus on the completing the square expression. And in particular, we are going to focus on how the exercises are presented here in the A levels, because that is essentially what then will be doing. It's like, okay, we have a lot to do with completing the square. There's a very interesting videos there are very interesting videos on how to work with this, but I want to focus especially on how we can use the method to our advantage. And we're going to take a look at an exercise. The exercise states that we have to express this x squared plus 8x minus 7. This, I want to write it in the form of x plus a squared plus b, where a and b are numbers that I want to find. Why is it that we say that we are completing the square? Because we are making this square appear. There's a very interesting video. I probably will be getting the link in the description because it's very well explained how the completing the square works and why it works. But I'm going to attempt now in this video to show you the process that we can do for the A levels, like straightforward. So the idea is we are going to focus on how this would become this. So let's start expanding and let's say, well, okay, so if I have this, this I'm going to take here, this is going to be x plus a squared plus b. This is, I'm going to expand the brackets. I'm going to have an x squared. Then we have the double product of these two is going to be plus 2ax. And then we have plus a squared. And then we have the plus b, right? We have this plus b there that we cannot forget about. So what's the idea here? We're going to focus on how we can make this resemble this. Observe that we have here x squared, x squared. They are the same, so we don't need to do anything with this. We have x squared, we have squared. That's great. Now we're going to focus on the term that has an x. 2ax has to be equal to this part, to the 8x. Clearly you can see that the x's will cancel out. And then we will be getting that 2a is equal to x. So a is equal to 4. Thus, we have found the value for a. A is equal to 4. Because we need to have that the things that have the terms that have x, this one and this one, they must have the same value. So this 2a has to be 8, and thus a has to be 4. And then we have the constant term. In this case, this is negative 7. And here we have a squared plus b. These are the terms that have no x. So a squared plus b has to be equal to negative 7. But then the interesting thing is that we already know a, because a, we have already found it. A is 4. So this is going to be 4 squared plus b is equal to negative 7. This is 16. 16 plus b is negative 7. And thus, we can get that b is negative 7 minus 16. We're subtracting 16. It's going to be negative 23. So we have found that a is 4 and b is negative 23. So what is it that we can say from here? Okay, well, we can say that this beautiful x squared plus 8x minus 7 can be rewritten as x plus 4 squared minus 23. This may not seem like quite a discovery for you just yet, but this is a very interesting process for us to do. These squares are very useful because, for example, imagine that you wanted to solve this equation. Let's say that you wanted to solve x squared plus 8x minus 7 equals 0. You would have to either go for the factorizing method or to the general formula we're going to be going over later. But this is the same as doing this, x plus 4 squared minus 23 equals 0. And then I can just start solving, because then I can say, okay, so it's going to be x plus 4 squared equal 23. and then I can say, well, I'm going to take the square root on both sides, so it's going to be x plus 4 is equal to plus or minus the square root of 23, and then I just subtract 4, and thus I will be getting that x is equal to 4 plus negative 4, sorry, plus or minus the square root of 23, and that will be done. I would be just in 4 lines done with the equation. This root is like quite horrible, and I don't know if I would have gotten somewhere close with the factorizing method, for example. So it's an interesting process for you to have in your right pocket in case you may need it, and it's going to be very useful when we're going to be working with maximum and minimums on quadratics. When we get to studying the parabolas and the graphs, this method will help us a lot finding maximums and minimums. So it is something to consider here. The last method that we're going to work on, that is here in Uruguay the most common method, is the quadratic formula. The quadratic formula states that if we have an equation that is ax squared plus bx plus c equal to 0, then the solutions are given by x is equal to negative b plus or minus b squared minus 4 times a times c, everything divided to a. Here in Uruguay, we call this Bhaskara's formula. I know that this is not universal. Some students may use it. In English, we call it the quadratic or the general formula. And it's as straightforward as you can say it. You just plug in the values for a, b, and c, and you start operating. So, for example, let's say that we're going to solve 6x squared minus 3x minus 2 equals 0. I have no idea what this may give me. I know that we have two solutions because this is positive and this is negative, so we have to have two solutions. But then we'll see where we get there. So now we plug in. Okay, so we must observe that a, that is the number that the term is multiplying the x squared, is going to be 6. Then we have the b here, that is the number that is multiplying the x, that's going to be negative 3, bear the signs. And then finally, the constant term over here, that is going to be c, is going to be negative 2. So from there, we can focus on using the formula. We can say, well, okay, so x is going to be the opposite of b, so it's going to be 3 plus or minus the square root of negative 3 squared minus 4 times 6 times negative 2, and then everything here over 2 times 6. So then we just start operating. Okay, we'll say, yeah. So we have 3 plus or minus 3 squared, negative 3 squared is going to be 9. And here we have 4 times 6 times 2. I forgot the parenthesis there. 4 times 6 times 2 gives you 48. And negative times a negative is a positive, so it's going to be plus 48. And then we're going to divide everything over 12. This is equal to 3 plus or minus the square root of 57 divided over 12. And the square root of 57 is quite a horrible number that we cannot make any simpler. We can just leave it at this. This will be like the most exact solution that we can give. In case we wanted to make it rounded, we can go to our calculators and find the values and take some rounded numbers, but this would be quite an acceptable solution for us to work when working with the quadratic formula. So, as a general comment, before we close up this first video on the topic on quadratics, is that we have three methods that we can use: the factorizing method, completing the square, and the quadratic formula. No method is greater than the other, they're just different, and depending on the case, you as a student may find a method more useful than the other, or you may also feel that depending on the equation that you have, you may prefer to use one or the other. As I was telling you, for A levels, you can use whatever method you want. The only thing that you may be asked is to complete the square. That is something that we did earlier. So from there, you can have like the idea on how to work on it. We're going to see more on that when we get to study parabolas themselves. So this is like the first glance on how to solve equations. I hope that this was clear to you. Remember that if you have any questions, you can go over to the comment section and keep on adding suggestions and everything you may need to know. So thank you for watching, and I will see you in the next video.